Right now, as you are watching this, the strongest earthquake on the entire planet today happened in a place where not one human being felt it. At 5:22 in the morning, local time on Saturday, August 22nd, 2026, a magnitude 6.2 earthquake struck the Scotia Sea in the South Atlantic Ocean, roughly 90 kilometers from the coast of Antarctica. The depth could not be determined, assumed shallow. No felt reports. Not one. It was by magnitude the largest event recorded anywhere on Earth that day. The following morning, a magnitude 6.0 struck off Arimo, Hokkaido, Japan at 42 kilometers depth. A magnitude 5.3 struck the southern mid-Atlantic ridge at 10 kilometers depth. Across that same 24-hour window, global catalogs logged more than 1,100 earthquakes worldwide and over 13,000 across the week. The South Atlantic is the loneliest seismic zone on Earth. It is also the one place where a great earthquake once released 70% of its energy so quietly that the world's warning systems very nearly missed it entirely. So today we are going to break down exactly what happened on Saturday, why an earthquake this size in this location matters far more than the headlines suggest, and what the honest hazard picture is for the 4 continents that share this ocean. No guessing, no dramatizing, just the facts, the science, and the real stakes. Drop a comment right now and tell me this. Have you ever personally felt an earthquake? Not seen one on the news? Felt one. Tell me the country, the year, and what the first 2 seconds were actually like. And if you live on an Atlantic coast, Brazil, Argentina, West Africa, Portugal, the Caribbean, the eastern United States, tell me whether you have ever once heard a tsunami warning in your life. I want to see that split in the comments. If you want to be the first to know every time the ground moves somewhere significant, subscribe right now. It is completely free. A thumbs up helps enormously. Let us go for 5,000 likes so the algorithm pushes this to people who actually need to see it. Let us start with where this earthquake happened, because the location is the entire story. The Scotia Sea sits between the southern tip of South America and the Antarctic Peninsula, bounded on its eastern edge by an arc of small volcanic islands called the South Sandwich Islands. They are uninhabited. They lie about 3,000 kilometers southwest of Africa, 700 kilometers southeast of South Georgia Island, 1,600 kilometers east of Tierra del Fuego, and 1,700 kilometers northeast of the Antarctic Peninsula. That is the geography of isolation. And beneath it sits one of the most active plate boundaries on the planet. Here the South American plate is subducting beneath the small South Sandwich plate along the South Sandwich Trench at a rate of roughly 7 centimeters per year. Let me put that number in context, because it is the detail that makes this region matter. Cascadia, off the Pacific Northwest of the United States, converges at about 4 centimeters a year. The South Sandwich system is running nearly twice that speed. Faster convergence means strain accumulating faster, which means more frequent large earthquakes. So an M6.2 here is not an anomaly. It is the system operating exactly as it always has. There is a second reason this corner of the world produces so much seismicity, and it has to do with the shape of the arc. The South Sandwich Trench curves sharply. The strike of the trench rotates as you travel along it, which means the direction the plates are pushing changes from one end of the arc to the other. Where a subduction zone is curved rather than straight, the stresses do not resolve cleanly. Segments twist against each other. Faults form perpendicular to the trench as well as parallel to it. That geometry produces a much messier, more continuous stream of moderate earthquakes than a straight boundary would. And let me be precise about what magnitude 6.2 actually means, because the number gets thrown around carelessly. The magnitude scale is logarithmic. Each full step up represents roughly 32 times more energy released. A magnitude 6.2 releases something on the order of 10 to 15 times more energy than the magnitude 5.3 that struck the mid-Atlantic ridge the following day, and something like 1,000th of the energy of a great magnitude 8. In an inhabited region with poor building stock and a shallow hypocenter, a 6.2 is a serious event, the kind that damages unreinforced masonry, brings down older concrete, and kills people. In the open ocean, 90 kilometers from the nearest ice shelf, it is a line in a catalog. That gap between what an earthquake is and what an earthquake does is the entire subject of this channel. Magnitude describes the rock. Consequence describes what human beings built on top of it. Now let me explain that unresolved depth, because it tells you something important about how seismology actually works. To locate an earthquake precisely, latitude, longitude, and crucially depth, you need arrival times from seismometers positioned around it at many different angles. Seismologists call the missing coverage the azimuthal gap. Around the South Sandwich Trench, the nearest permanent stations are hundreds to thousands of kilometers away, mostly clustered on one side. There are no instruments to the east or south because there is nothing there but ocean and ice. The result is that depth becomes the least well-constrained parameter in the solution. Analysts frequently default to a fixed value of 10 kilometers, and the initial reporting on Saturday's event simply stated that depth could not be determined and was assumed shallow. That is not sloppiness. It is a physical limitation, and it is the same limitation that produced the most important seismological surprise of the last decade in this exact stretch of ocean. On August 12, 2021, at 18:32:52 UTC, the United States Geological Survey reported a magnitude 7.5 earthquake in the South Sandwich Islands, the result of reverse faulting at approximately 63 kilometers depth in the Scotia subduction zone. 3 minutes later, a second and far larger earthquake struck the same area. And here is the problem. The seismic waves from the first event were still arriving at stations around the world when the second one began. The first quake's signature masked the seconds. The instruments were saturated. What eventually resolved as a magnitude between 8.1 and 8.3 initially appeared on the surface wave and body wave measurements as something much smaller. It gets stranger. Later analysis of that main shock revealed it was not one clean rupture, but a sequence of at least 4 distinct episodes over roughly 280 seconds. Sandwiched between a fast start and a fast finish was a slow sub-event that propagated at about 1 kilometer per second, compared to the roughly 3 kilometers per second typical of subduction thrust earthquakes, traveling around 200 kilometers along the plate interface. That slow phase accounted for approximately 70% of the total seismic moment. Let me make plain what that means, because it is the single most important concept in this video. Seismometers are most sensitive to short-period, high-frequency energy, the sharp crack of rock breaking fast. A rupture that moves slowly generates very little of that. It is nearly silent in the frequency band our alarms listen to, but the seafloor still moves. The rupture still lifts 1 to 2 meters of ocean floor across hundreds of kilometers, and every cubic meter of water above it has to go somewhere. Seismologists call this a tsunami earthquake, an event that generates a tsunami dramatically out of proportion to how big it sounds on the instruments. The result in 2021 was a tsunami that crossed the planet. Tide gauges recorded it at the Azores in the North Atlantic, around 20 centimeters, 14 hours after the rupture. Eastern Madagascar in the Indian Ocean, about 6 centimeters, also 14 hours out. The wave was tracked as far as the far northeastern corner of the Pacific. That earthquake is tied with a 1929 event as the largest ever recorded in the South Atlantic region. Nobody died, because there was nobody there. Now let us do the comparison that decides whether that stays true, because the world has run this experiment twice and got 2 completely different answers. After a Pacific tsunami killed people in Hawaii in 1946, the United States built the Pacific Tsunami Warning Center. After the 1960 Chilean earthquake sent waves across the entire Pacific basin, that system was expanded internationally. After the Indian Ocean tsunami of December 2004 killed more than 200,000 people across 14 countries, UNESCO coordinated the creation of a dedicated Indian Ocean warning system. 26 member states sharing seismic data and deep ocean buoy coverage, with regional service providers in Australia, India, and Indonesia. The Caribbean got its own intergovernmental system covering the Puerto Rico Trench. The northeastern Atlantic and Mediterranean got theirs, with service providers in Portugal, France, Italy, Greece, and Turkey. Every one of those systems was built after a disaster, not before one. And the deep ocean instruments that actually confirm a tsunami has formed, pressure recorders anchored to the seafloor, paired with surface buoys reporting in real time, are concentrated where those systems were built. NOAA operates 39 of them across the Pacific, Atlantic, and Caribbean basins. The southern reaches of the Atlantic, between South America, Africa, and Antarctica, are not covered at anything approaching the same density. There is no dedicated intergovernmental warning system for the South Atlantic comparable to the Pacific, Indian Ocean, Caribbean, or Northeastern Atlantic arrangements. The lesson is not that officials are negligent, it is more uncomfortable than that. Warning infrastructure follows casualties. Where nobody has died yet, nobody funds the buoys. And the Atlantic has already demonstrated what it is capable of. On the 1st of November, 1755, a great earthquake, estimated between magnitude 8.5 and 9D, struck southwest of Cape St. Vincent in the Atlantic. Lisbon was destroyed by shaking, then by tsunami, then by fire. Estimates of the dead run into the tens of thousands. The waves crossed the ocean and were recorded in the Caribbean. That earthquake shattered European philosophy and effectively founded the discipline of seismology. The Atlantic is not a safe ocean, it is a quiet one. Those are different things, so when you see a headline reading, "Breaking magnitude 6.2 strikes the South Atlantic," the natural instinct is to ask whether something is building. Is this region becoming more active? The honest scientific answer is no, but the picture is more nuanced than a simple no. The planet produces several thousand detectable earthquakes every day, the overwhelming majority far too small for anyone to feel. Magnitude 6 and above occurs roughly 120 to 140 times a year, about 1 every 3 days. A single M6.2 in a subduction zone converging at 7 centimeters a year is not a signal. It is the baseline. The systems are also independent. Saturday's Scotia Sea event and the Mid-Atlantic Ridge event the following day come from completely different mechanics. The Scotia Arc is a subduction zone, one plate driving beneath another. The Mid-Atlantic Ridge is a spreading center where new seafloor is created as plates pull apart. Ridge earthquakes are shallow, frequent, and rarely exceed magnitude 6 because the crust there is thin, hot, and weak. There is no physical mechanism by which one loads the other. What has genuinely changed is not the geology, it is the resolution of our attention. Global networks now detect and publish events within minutes that 50 years ago would have gone entirely unrecorded. A magnitude 6.2 off Antarctica in 1960 would have been a line in a bulletin weeks later, if that. Today, it is a push notification. And one more thing has changed, which almost nobody discusses. That ocean floor now carries the submarine cables that move nearly all intercontinental data traffic on Earth. Remote does not mean disconnected. This is not theoretical, and the precedent is one of the most elegant accidents in the history of geoscience. In November 1929, a magnitude 7.2 earthquake struck the Grand Banks off Newfoundland in the North Atlantic. It killed 28 people when a tsunami came ashore on the Burin Peninsula with no warning. But it also did something stranger. It snapped a series of transatlantic telegraph cables laid across the seafloor, and it snapped them one after another, in sequence, moving downslope. Because the cable companies logged the exact minute each line went dead, scientists were later able to work backward and calculate how fast the thing that cut them had traveled. The answer was that a vast underwater avalanche of sediment had raced down the continental slope at speeds estimated in the tens of kilometers per hour for hundreds of kilometers. That reconstruction is how the phenomenon of turbidity currents was established as real. A telegraph billing record became a scientific instrument. The lesson transfers directly. Undersea earthquakes in places nobody lives can still reach into the lives of people 10,000 kilometers away, through the water and through the wires. Let us be direct about the practical message here, because information without action is just anxiety. The 2021 event proved that a great earthquake can hide inside its own slow rupture and still send a wave across 3 oceans. Warning centers now know to look for it, but detection depends on instruments, and instruments follow funding, and funding has historically followed body counts. Lisbon proved the Atlantic can kill at scale. The Grand Banks proved that a remote seafloor rupture can reach a coastline before anyone has said a word about it. The South Sandwich Islands proved the Atlantic can still generate globe-crossing tsunamis today, in the modern era, with modern instruments watching. And notice what all 3 have in common. In none of them did the population have a warning. In 1755, there was no science. In 1929, there was no system. In 2021, there was a system. And the earthquake was quiet enough that the system struggled to size it in real time. The technology improved enormously across those 266 years. The number of minutes an ordinary person actually got did not improve nearly as much. Here is what you can control wherever you live on a coast. Learn one rule and it overrides everything. If you are near the coast and the shaking is strong enough that standing is difficult, or if it lasts longer than about 20 seconds, move to high ground immediately without waiting for an official alert. In near-source events, the wave can arrive before any warning is issued. Know where high ground is from your home, your workplace, and your children's school, on foot, not by car. Learn the distance and time at once. Enable emergency alerts on your phone and know which agency issues them for your coast. Keep a go bag with water, medication, sturdy shoes, and a torch by the door. Keep 2 weeks of supplies if you are coastal and remote. Agree one out-of-area family contact everyone texts because local networks fail while long-distance data often survives. And if you live in a country with no tsunami warning coverage, understand that the earthquake itself is your warning system and act accordingly. Final thought. The South American plate has been sliding beneath the South Sandwich plate for millions of years, 7 centimeters at a time, and it will keep doing so long after every person watching this is gone. On Saturday, it released a magnitude 6.2 into an empty ocean, and the only witnesses were instruments on distant continents that could not even agree on how deep it was. We cannot stop these earthquakes. We cannot predict them. What we can decide is whether we instrument an ocean before it kills someone or after. Lisbon showed what the Atlantic does to a city that never imagined it was at risk. The South Sandwich Islands showed what a modern great earthquake looks like when it whispers instead of shouting, and how close the world's warning systems came to missing it entirely. Saturday's earthquake harmed nobody. That is genuinely good news. It is also the only kind of warning this ocean has ever given us in advance. We will keep tracking every significant event as it happens. Subscribe so you do not miss it, and leave that comment below. Have you ever personally felt an earthquake, and have you ever heard a tsunami warning where you live? Because these are not just geological events. They are human decisions.